Right, so this is the required practical for waves, okay, specifically ripples on a ripple tank. So before we start that, let's have a think about how we could determine the thickness of a single piece of paper. The problem with a piece of paper is it's so thin. So what we can do is do a trick. Okay, we would measure all 500 sheets in a packet, measure its thickness, and then let's say it's 10 centimeters. Then we divide it by 500 to get the thickness of just one of those sheets. Okay, and that's what we'd do. Now, it's a similar sort of thing here. The diagram below shows some water waves. You could work out the wavelength of one of the waves by measuring it with a ruler, but it would not be very accurate because it's very narrow. Okay, it's not very long. So a wavelength would be from one dark area to the next dark area. Okay, also it's moving, which makes it really hard to measure as well. So the first thing we would do is we would pause it by taking a photo. And once we've paused it by taking a photo, we would then measure 10 waves. We would measure more waves just like we measured more pieces of paper. So here we can see 10 waves is 6 millimeters. Okay, so then we would do 6 millimeters divided by 10. Okay, that gives us 0.6 millimeters. So that means each wave would be 0.6 millimeters. So the wavelength is 0.6 millimeters. Okay, remember one wavelength is from one black area to the next black area, and 10 waves fit between these red arrows. So as I said, they're moving, just take a photo, and that freezes them in place. Now, frequency is the number of waves that pass a point in a single second. It's measured in hertz. Counting how many waves pass a point in a second is not very accurate. So imagine if we had this point here and we counted how many waves passed a point in a second. It would not be very accurate because a second isn't very long. So what we do is we count how many waves pass a point in 10 seconds, then divide by 10. So if we do that, we go, let's do it now. So let's do it when the black one's there. So we've got 1, 2, 3, 4, 5, 6, 7. Now 10 seconds have passed. So what we've got is I've counted 7 waves in 10 seconds. Now the problem is frequency is the number of waves in a second. So we'd just do 7 divided by 10, which gives us 0.7. So that's 0.7 waves past that arrow in the second. So the frequency would be 0.7 hertz. Now, obviously, you can't take a photo of this because you need to count the number of waves when they're moving. But what you could do is take a video, okay, with a picture with a stopwatch in it, and then you can count how many waves pass that particular point in the 10 seconds indicated by the stopwatch that's in the video as well. Okay, so and you could slow that video down to make it easier to count. So let's go through these, pause the video and answer the questions, and then hear the answers. So wavelengths are always measured in meters because it's a length. Frequency is measured in hertz. Describe how accurately measure the wavelength of a set of waves. Measure 10 waves and divide by 10. How could you accurately measure the frequency? Count the number of waves in 10 seconds, then divide by 10. Use the diagram below to calculate the wavelength. So we know that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 waves is 100 meters. Okay, so what we do is 100 divided by the 10 waves, which means each wave is going to be 10 meters. So the wavelength is 10 meters. So here we can see we've got 10 waves, and it's taken 5 seconds for 10 waves to pass. Okay, so these waves are moving, and to get all 10 waves past a particular point, let's say where my cursor is, that's taken 5 seconds. So all we do is 10 waves divided by 5 seconds gives us 2 hertz, because that's 2 waves per second. Now, here is an example of a ripple tank. Now, it is a simulation of one, okay, but a ripple tank is just a piece of, or tray with water in it, and there's a bit of wood that bobs up and down, which you can see here, that creates waves. Okay, so what we're going to do is I've made the waves easier to see with these red arrows. So each of these red arrows is a peak of a wave. Okay, so what we need to do is work out a series of information So we need to work out the frequency first. So we get the frequency from the signal generator. So we can see here that the signal generator, that's what makes the thing bob up and down, is 3 hertz. So our frequency is 3 hertz. Then we want to measure wavelength accurately. So what we do is we measure 10 waves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We know 10 waves here is 50 centimeters. And 50 centimeters is 0.5 meters. We tell by the ruler. So you do 0.5 divided by 10, means the wavelength is 0.05. Now we know frequency and we know wavelength. We can times them together to get wave speed. And remember, you will get that equation to work out wave speed on your equation sheet. Now you just keep doing this for different frequencies. So we can see here we've got a different frequency because they've moved close together, and it says they're 4 hertz. So we've got 4 hertz. We measure the length of 10 waves. So here we've got 35, 36, 37 and a half. 37 and a half is 0.375 meters because we divide it by 100. And then if 10 waves is 0.375 meters, we divide it by 10 to get just one wave, which is that. And we do frequency times wavelength to give us 0.15 again. Now we change again, okay? And we do the frequency, which is 5 hertz. And now we've got 10 waves that are 30 centimeters. So 30 centimeters is 0.3 meters. We want to divide it by 10 just to get one wave, which is 0.03 meters. So we know the wavelength is 0.03, and we know the frequency is 5 hertz. Times that together, we get 0.15 again. So hopefully you're seeing the common theme that the wave speed remains constant. Now, finally, we've got the frequency of 6 hertz. Okay, so we write 6 hertz down. Length of 10 waves in this case is 25 centimeters, which is 0.25 meters. So we then divide that by 10 just to get one wave, which is 0.025. And then what we do is frequency times by wavelength, which gives us 0.15. Okay, so there is an alternative method. Okay, and we could use speed equals distance divided by time. So we just take a single wave crest, okay, and we measure a set distance. So we measure the distance traveled. So we might want to measure that crest from here to here, and then we measure the distance traveled by wave with a ruler in 10 seconds. Okay, so we start the stopwatch there, and we watch it for 10 seconds. Okay, and then we stop it there. Let's say it got there in 10 seconds. So it went from there to there in 10 seconds. So that's our distance measured. And then because speed is distance divided by time, we do distance, which is what we measured, divided by the time, which is 10, gives us speed. Okay. Now here is some past exam questions. The diagram below shows a ripple tank that a student used to investigate water waves. The student adjusted the speed of the motor so that the bar hit the water more times each second. What happens to the frequency of the waves produced? So if it hits more per second, there's going to be more waves produced in a second. So that means the frequency has increased. Describe how the frequency of the water waves in the ripple tank can be measured. So we've done this. We count how many waves pass a point in 10 seconds, then divide it by 10. That's an accurate way of doing it. Okay, so count how many waves pass a point in 10 seconds, then divide by 10. A teacher demonstrated some features of waves using a ripple tank. Figure below shows the ripple tank. The teacher measured the time taken for 10 wave fronts to pass the mark. The teacher repeated this measurement 3 times and calculated the mean. What is the advantage of repeated measurements and calculating the mean? It's always the same answer for this, okay? It reduces random error and makes it more accurate. Okay, if you noticed one that was completely wrong, you could discount that as well. Finally, in a different investigation, the teacher wanted to determine the speed of water waves in a ripple tank. The teacher did not measure the wavelength of the wave. Explain how the teacher could determine the speed of the wave. So we know speed equals distance divided by time. So all we do is time how far, or time a wave for 10 seconds, measure the distance it travels in that 10 seconds, and then do the distance divided by 10. So measure the distance traveled by wave with a ruler in 10 seconds using a stopwatch. And then do distance that you measured divided by time, which is the 10 seconds. That would give you speed. Thank you very much. Hopefully that was useful.